Hello, how are you? I see a lot of familiar faces, so I probably talked to a lot of you at our booth at Talsec downstairs. Uh, so, how are you feeling? It's your third day at the conference. You seem like tired, but I believe that you've seen a lot of great talks. So, I believe that you are now looking forward what will come. Uh, to introduce myself, I am Tomáš and I'm security consultant in Talsec. And we are a mobile security company focused on mobile shielding. But in this talk, I would like to show you some landscape of mobile security that's relevant for Flutter developers like you. So, who am I? I currently work on a security library that can detect things like routing, jailbreaking, and other common mobile attack vectors. And also I work on backend oriented technology that can prevent attacks on your backend, and it basically locks your applications to your backend and forbids any other network requests. So that's my current job. And with this talk, I wanted to show what's needed to protect your mobile apps on Android and iOS. And also, I would like to thank the organizers who did a great work at this conference. I think that they prepared a stunning conference, and I really love how many people joined this conference. So thank you for joining this conference and joining this talk. I think you are doing a great job, and I'm really happy that I can talk to such an attentive audience. Last year, there were half people. So it seems that Flutter security awareness is going up. So that's perfect. Okay, yesterday I did a small prank, and I put this this paper on our booth, and then I counted how many people will get the joke. So how many of you get this joke? Raise your hands. Oh, good, perfect. Yet, as I said at the start, the developer awareness, speaking of threat modeling and understanding what's the threat landscape at mobile apps, is quite low at Flutter. My opinion, it's just opinion, is that people who started with Flutter were used to mobile technologies and didn't have a lot of assets to protect within the application, because more web applications have a smaller attack surface, let's say it. So I want to raise this awareness, and that's why I prepared this talk. For me, there is something called availability heuristics. That's that you developers often rely on available information when assessing risks. And when you don't recall many instances on certain threats, like some malware attacks, then you may underestimate the likelihood of an attack. So that's another reason why it's important to make such talk. So, hacking is real. I searched the internet, visited every Reddit forum, and found dozens of real-world stories of people who were hacked or whose application was hacked. People usually are angry and trying to fix things once it's too late. It's unfortunate. When you will search for security in mobile world, you will find millions of terms, and you may get lost. So if you would like to get some basics and to have some good reading, I can recommend you a really good source, and that's OWASP Mobile Application Standard. I bet you've heard about OWASP. And today, there is a new OWASP mobile application standard that's developing a new framework for assessing and working with security in mobile applications. So it's now reaching a beta version, and it will be released soon. So search for that. We will definitely benefit from that. And another great resource for Flutter developers is a new Flutter engineering book written by Majid. Do you know Majid? He is one of the greatest guy in the Flutter community who does a lot for our community. So I recommend chapter 18. So if you open the book, navigate to chapter 18, you will find what's Flutter-specific security best practices. You will find a lot about what are foundational principles of security in Flutter apps. So a really great resource if you want to dive deeper into security. So what's threat modeling? First, you need to understand your own organization and your line of business. That's one of the common issues we got when a customer asks us or me for a penetration testing or like assessing their security of their applications. I simply don't know about your application, and if you don't tell me how your business is structured, how or what's valuable in your application, I simply don't know. So it's important that developers are aware what's the asset in their application. It might be user account, it may be some valuable machine learning model, or other sensitive assets. So you need to be aware what's your line of business and what you need to prevent against. The next step is to assess, to do a logical security architecture review. So you have to have some methodology how to describe and monitor a whole process, so you know how it looks like. And you need to define those assets precisely. Then you can identify the vulnerabilities, threats, and risks, and work with that. And once you understand your line of business and have defined these assets, you are able to review if your countermeasures are enough, if they protect what you need, and you can analyze possible gaps in your security and do other stuff like monitor and maybe measure your security process. And one of the important concepts in every application, even in web-based or mobile application world, is tofu. And I don't mean the food, I mean trust on first use. Because once your application lands on the final device, you have no control, you have zero control about the quality and security of the device. You just simply don't know who is now using your application. Yet you want to have some source of trust there. So you have to address questions like whether the device is safe for the app's operation, or if there are any signs of malicious activity, or if your application is still yours. Maybe someone repackaged it or injected some malware. So these are questions you need to address when your application lands. It's also similarly called application enrollment, or device or user enrollment. So people often argue with me whether the application sandbox is enough. Typically on Android and iOS, applications are sandboxed, so they can't be simply injected or attacked or reverse engineered. But there are many, many ways how you can breach this sandboxing concept. For example, you may have rooted phones. It's simple, everyone can try it yourself. So rooting phones or emulators is like a matter of minutes. Another case are emulators. Those might already come pre-rooted. By rooting, I mean that an attacker with root privilege, like escalated privilege, can do whatever he needs with your application, with your stored data within application, everything. And other attack surface is through like third-party malware dependencies, because honestly, how many of you can swear they know what's included in dependencies you use in your project? Have you checked the source code, or possibly so your dependencies were closed source, you even couldn't check what's inside? So malware can get through this way. Of course, there are continuously found new vulnerabilities in operating systems. You may check Android website where there is a monthly bulletin with all fixed remote control execution or other issues. And another vector might be even hardware. For example, on Android, it's very commonly exploited, the Bluetooth stack. Even, I think it was like 2 months ago, there was some new vulnerability that allowed to like completely get control of like user's device remotely. And of course, someone may repackage your application, and at the moment, it's truly not your application. Like, if you would like to try hacking or like to learn hacking tools yourself, there's a short list you could use. So for start, you will need some rooted device. You will maybe equip device with kernel, SU, Magisk. If it's iPhone, you will probably jailbreak it with dopamine. You may try Frida, that's used for like instrumenting application at runtime. You may test APK2, that's used to like rebuild application after repackaging. And a really good tool I could recommend you is Mobile Security Framework, acronym MobSF. This is a statistical analysis tool that will help you to uncover various stored things in your application. So it's mostly drag and drop tool. I think it was already showcased at this conference yesterday. So if we were at another security talk, there was a great talk about MobSF. And if you really want to delve deeper, you can check IDA Pro, Guidera, or other like decompilers are the serious stuff. Speaking of Flutter, there are emerging new hacking tools like Reflutter or Blutter or Flutter Spy. Those are like command line tools that can exfiltrate data and help you like what's processed within the application. So another great recommendation, you may try and see what's in your application and what attackers can exploit. So like first threat model, like what can be like a whole category important to you is app cloning. That means like repackaging, pirate copies, or social engineering that leads to like spreading fake versions of your applications between your users. This may lead to data breaches, leakage of personal information, or financial loss. I have a great story. So back in the day, I interviewed a friend of mine whose application was hacked. He developed an application called Better Vision for visibility impaired people. And this application was like really successful. A lot of people started using it. But some attacker realized that it's like a really great application and that he could like do something. And what attackers did was that they took the application, repackaged the application, and injected their own payment gate. I think they set some lower price or something like that. And then they spread this application between users. So because of this hacking, I have some number. Yes. So because of this hacking, the expected like income or profits were 4 times smaller than they were expected, because attackers were really successful at spreading the fake versions. So this was a huge impact on a business. My friend told that initially, as usual, they focused on development of features and like to getting application up and running, and they simply didn't have time or enough time to do a proper security and to focus on threat vectors and threat modeling. So this may be like great example what may happen if you underestimate the needs for security. So the repackaging attack I talked about is quite simple. You just take the APK tool, the final APK, you can download apps from Play Store directly, and then you can inject various things into the application. Like I have a few examples there. You can inject code directly into main activity. I know that you are Flutter developers, you may be not aware of the underlying Android concepts, but even though it's Flutter application, there are still a lot of Android components within the application, and one of those is main activity. There's like an entry point for your code, and it's still present even in Dart application, in Flutter applications. So you can easily hook into this activity, inject smutty code or other like libraries, and create easily some malware. Common thing attackers do is to open some browser intent from within your application or hijack opening of your application. So whenever malware see that your application is being brought to foreground, they open instead a browser with some phishing site. And what I recently stumbled upon is a Game Guardian. That's a novel hacking forum or novel hacking tool that's nowadays really popular amongst hacking community to like breach security of gaming applications. So if you develop gaming applications, there is a really thriving community of reverse engineers who like to like maybe give unlimited turns or unlimited money in your game or do other cheats. So if you are mobile or game developers, you should be aware of this. Okay, another like category or threat model you need to be aware of is hooking. That's something you do with the Frida I mentioned before. It's similar to debugging. You just attach to a running application, and then you can inject scripts that can exfiltrate application at the runtime. So it's really simple. You just inject a few lines of JavaScript or Java code, and you can see, for example, cryptography or keys that are in the application, or check within or inject into encryption processes. So there are a lot of tools and a lot of tutorials how to use Frida. So I won't now bore you with that. But hooking is a really common hacking more threat attack, and I think it's great to know about it. I will jump over there. Like I said at the beginning, I am author of a library called FreeRasp. You may try to find it on GitHub. This application is free to use, and it can detect if your device is rooted, if there is a hooking attack, or if your application is not being repackaged. And we have a really thriving community of like security experts in the repository. So you may be interested to look at it and maybe try it in your application. FreeRASP can, for example, create reports. So once a week, you will get a PDF with like security statistics of your application. And I think that's a really great initiative. So I'm also very thankful to everyone in this room who already used this application, because from the last year, this time I've talked like to dozens of people who already use FreeRASP and really like it. Okay, the third thread model that I would like to talk about today is like reverse engineering. Like everything I talked about is reverse engineering, but when I talk about reverse engineering, I mean like really hardcore reverse engineering, like decompiling of your code and learning internal workings. And this can lead to, of course, leakage of your sensitive data or algorithms or your encryption keys. And for example, someone may try to steal your transmitted data and like check your traffic. So for reverse engineering, what I did in the past, I reverse engineered one gaming platform which stored all the like data that are needed to for business operation, like ID, JOT token, or how many you have free games or daily free games in shared preferences. That's a simple XML file stored within an application, and I could easily find a lot of sensitive information over there, and I could edit it. For example, I could get unlimited free games. So this way you can exfiltrate, for example, such things. Also, you can find on YouTube my video from access token theft. I think I did a BMW application, and there were some tokens and things like that. So if you are interested, check on YouTube. There is a really great video about JOT token stealing, and it's quite simple to steal JOT tokens. I believe a lot of you already know what's JOT token, but simply put, it's token that you use to authenticate the instance of your application. And as I claimed, I will be talking on API protection as well. Speaking of API protection, you need to ensure that your backend is talking only to your legitimate applications, your legitimate devices and users, and no one else. Typically, that's something you would solve with API key, right? But since we already know that stealing API keys is simple as that, there is like need to do more in this area. And one of the things we do at Talsec is attestation called Epicrypt. And with that, we can prevent attacks like against your API architecture or against like various scrapers, scripters, or other reverse engineering script kiddies. Because in your application, it's quite simple to find out what's your API structure, because you probably hard code what's your endpoints and things like that. And it's really simple to exfiltrate source links and IP addresses. So it's really simple work for attacker to find out how your network works, like how are your network calls structured and how your JSON structures look. So it's needed to do something more. So I took this BMW application. It was written in Flutter, and it allows users to, for example, switch on lights, turn on air conditioning, open trunk, and other stuff with their car. And then I decompiled it and searched for sensitive assets within the application. Everything of these things is not sensitive now, so don't worry, I'm not like disclosing anything, okay? And I could like capture every network traffic within my burp suite. So I could easily see, for example, this was some advertising campaign within the application. And I could also replay some network calls to open that trunk and things like that. The like inner workings were stored, or like some helping data were stored again in shared preferences. So this is how the shared preferences looked. And in the shared preferences, there was stored my JOT token, since I signed up in the application. So with this JOT token, I could, this is the JOT token, the respective JOT token. I wanted to show you how JOT token looks like. So you can see that with JOT token, you can directly see my email address somewhere. Yes, it's there. You can also see other things. So this is how JOT token looks like for those who haven't seen the inner content of JOT token. And one of the like mass attacks that may exist is like, this is a full chain of attack, is that someone may, for example, repackage your application. That's possible, as we already know. Then spread it amongst users, and then harvest all these JOT tokens and use it, for example, for some malicious request against your backends. So this is basically how a lot of botnets work. So this is like a big scale attack that may be good to know about. Okay, speaking of the API and backend attacks, common ones are API abusal. I remember a case where we solved one customer had an issue that their API was scraped. That means that someone was exfiltrating data through the API to learn their, for example, prices of their shoes or something like that. And they wanted to prevent that. So scraping is also a valid attack that you may want to. It's like not security attacks, it's more like a business attack. Also important is to know that there is a lot of botnets. They are device farms that are automatically exfiltrating data from applications like those JOT tokens and doing attacks on your backends. Sorry. So what you can do to block traffic coming from unauthorized clients other than your application? So what are your options besides the API key? Another threat model is malware. There are dozens of SMS stealers, rat tools, keyloggers, or tab checking tools that may attack your application indirectly. For example, speaking of tab checking, it's like a transparent layer over your application that steals users' touches. So whenever, for example, a user enters his or her PIN, this application will steal the PIN and then forward those touches to your application, so you won't even know that something happened. Or a lot of malwares utilizes accessibility services, and then they can use this accessibility service permission to, for example, like instrument your application and enter data or exfiltrate inside the data or read like account balances. So there are a lot of malwares nowadays. I have one example later. So here is an example of screen logger I did. This screen logger can read whatever is written in any application on device. So if such a malware gets onto user's device, anything users will write or like type in can be captured within the screen logger. And this screen logger can then forward those data to attackers' command and control server, and those data can be misused further. And one of the emerging threats are RAT tools. This raffle RAT is quite common today, but you will find other RAT tools. RAT tools can, I copied the listing from README, are able to get total control over user's device. What it means is that, for example, if you want to do a second factor authorization through SMS, such tool can read SMS messages and then forward those temporary password to attacker's command and control server. So Rust tools are quite powerful, and sometimes they can be installed through some, like I said before, Bluetooth vulnerabilities. So this is one of the threats you should again be aware about. Okay, I put a simple table here. So what you can do for respective attacks. Speaking of like routing attack, you need to know that the risk is that someone can steal your application's data. In that case, you can use some root detection library. If it's some complex reverse engineering, you need to, of course, employ many more protections like TLS pinning or secure storage or obfuscation. For man-in-the-middle attacks, you need to employ certificate pinning, either static or dynamic. And for hooking, you can again rely on some ready-made root or hooking detection library. For malware, you may need RASP with UI protection. And I now think I didn't say what RASP means. Those RASP libraries are like mobile shielding libraries are working during the application's runtime. So it's like included in your application and monitoring the state of the application. So it's runtime application self-protection acronym. And the most complex kit you can use to prevent attacks on your mobile backend is something like attestation, like Play Integrity or AppyCrypt or other similar technologies. So that was like brief introduction to mobile attacks and threat modeling. So if you have some questions or you are interested to learn more, please grab the microphone and I will try to answer. And otherwise, it was everything from me. So thank you for coming to this talk and enjoy the rest of conference.